In the previous video, we looked at various ways to authenticate to a Kubernetes cluster. Once you authenticated though, we can specify policies that control whether the user is able to perform certain actions or certain resources. Let's look at various authorization scenarios. First, a user needs to be given access to create pods in a development namespace but not production. Second, another user needs to be given access to list pods in all namespaces. Third, a group needs to be given access to list services and pods in development and production namespace. All these and other scenarios can be handled by using authorization policies. There are 4 different authorization modules such as Node, ABAC or Attribute-Based Access Control, RBAC or Role-Based Access Control, and Webhook. In this video, we will look at RBAC. To enable RBAC, pass in the flag test-authorization-mode equals RBAC. It is enabled by default in Minikube. RBAC is present in the rbac.authorization.k8s.io API group. There are two fundamental concepts in implementing RBAC, roles and role binding. Both of these are objects that can be maintained using a YAML file. Let's take a look at a YAML file that creates a role and role binding. This YAML file is part of the RBAC demo that I'll show in the next video. A role contains a list of rules that specify what a user or group is allowed to do. Each rule contains 3 parts: API groups, resources, and verbs. API groups tells which API groups the role allows access to. The resources are Kubernetes objects that are allowed access. They can be pods, services, etc. They can also be sub-resources such as pods/logs, that is all logs inside pods. A role can also refer to specific resources by name by using the resource names option in a rule. Verbs refer to actions that can be configured in the policy. Actions can be get, list, create, update, patch, watch, proxy, redirect, delete, and delete collection. In this YAML, the rule says that the role provides access to the extensions API group and allows get, watch, list, and create on deployments. The role provided rules about what can be done. To assign this role to a user or group, we use role binding. The second part of the YAML creates a role binding. The metadata specifies a name since the role needs to be bound in the same namespace in which the role was created. In other words, a role is bound to a namespace. The subject defines the entities that the role is applied to. The kind of subject can be user, group, and service account. The API group is an empty double quote for service accounts and rbac.authorization.k8s.io for user and group. Role reference refers to the role matched by the name. In addition to role and role binding, there are 2 other objects used by ABAC known as cluster role and cluster role binding. The difference between role and cluster role is that a cluster role is scoped to a whole cluster. So a cluster role can be used to assign permissions to cluster level resources such as nodes and also to assign permissions to all namespaces. A role binding can bind a user to a role or a cluster role. However, when bound to a cluster role, the binding is still restricted to a namespace. The advantage of using a cluster role with role binding is that it allows using the cluster role with any namespace. That is, you design a cluster role that allows listing pods, and you can use that in a role binding in a default namespace or production namespace, and so on. A cluster role binding is used to bind a subject to all the namespaces. So if you want to give a user permissions to list pod in all the namespaces, then you create a cluster role binding that uses a subject with a cluster role. In the next video, we will look at a demo of how RBAC can be used to give 2 different users permissions to the corresponding namespaces. See you in the next video.